Hi, today I will show you schematic of our temperature measurement project on Proteus. Moreover, I will explain how it works of the code we wrote with micro C, as you can see. Also, I'm gonna make this presentation on behalf of our team. The members of our team are Mert Büyükdoğan, Mesut Enes Arslan, and myself, Ali Baran Arslan. Let's look at our project. I will stop and run again. Okay. Firstly, I will introduce our materials. We use a microprocessor, and our microprocessor is PIC 16F877A. Stop the simulation. I want to show you how we upload our code inside the microprocessor. We click here, and as you can see, we upload our micro C code into our microprocessor as hex folder from here, and click OK, and run again our circuit. Now I will introduce our micro C code. Firstly, at the beginning, we define name to each control signal for 7-segment display from here, and it's our 7-segment display screen. And we define unsigned char. This array stores binary bit pattern that will be sent to port D. And we can see our temperature as Celsius and Fahrenheit thanks to that part of circuit. As you can see, 20 Celsius means that 68 Fahrenheit. And here variables store digital value and output voltage. And these functions show lower or higher threshold mode selected, and if select boot mode, prints error code. That means you can't select two threshold modes simultaneously. You just select one side at the same time, as you can see. I can just one side. Thanks to that 3-side switches, it provides us we can select just one part of this switch. Otherwise, if you select two switch pin at the same time, you will see error from our 7-segment display. But thanks to that switches, you can't see that kind of error from our circuit. Anyway, let's continue. And this function indicates with LEDs upper threshold or lower threshold value. If you look at here again, it's lower switches, and it's determine our lower threshold value, and higher switches, it means is higher threshold value. If right side of the switches is higher switch mode, and you can adjust our temperature, higher threshold temperature from here. Now I will set as 18 Celsius or 20, and a lower threshold value, again similarly, I can set it as 9 Celsius. Also, we can see it as Fahrenheit, as I mentioned about a few minutes ago. Okay. And also, thanks to that adjustment, we say that left side is lower switches, right side is higher switches, and at in the middle, you can see the temperature in our room or anywhere where we use this circuit. And thanks to LM35 module, you can see the room temperature and set any other temperature, any other Celsius or Fahrenheit. Or high threshold value was 20 and lower was 9. If our room temperature is greater than 20, like that, our LED red is open and turn on. If our temperature is lower than 9 Celsius, like that, our LED blue is open and turn on. That means our room temperature is very cold, and you can augment the temperature in the room until 21 Celsius because our upper limit was 20. This circuit process works like that, thanks to our code, and from here we explain that how we can see this number on 7-segment display screen. Thanks to that part of function, we can see the room temperature on the screen. And thanks to flag, set flag 100 because prevent adding repeatedly while button pressing. If we look at here, when I press the button 1, the temperature augment increasing 1. Thanks to here, we get this data from this part of code, and rest of them it's regarding with ports is not necessary about talking on it. Also, for this code, some libraries was necessary, and we choose ADC button, CMAT, STLib, string, S-type, and PWM libraries. These libraries are very crucial and important for our circuit. If we don't select this library, we can't see all these features, all the property on this circuit and simulation. And I will show again from this part. We can see the all temperature, all Celsius degrees as Fahrenheit at the same time with here. Thanks for watching.